All right, welcome back. And now we're going to talk about the basic properties of logs. And so these are the 4 properties of logs that you want to memorize and understand. And it's pretty easy to derive or explain why that these all hold. Okay, so the first one, log base b of 1 will always be equal to 0. Anytime you have this expression, log base b, so for any base of 1 is equal to 0. And quite simply, it's just because if you write it in exponential form, it's the same thing as saying b to what power, right? B to what power is equal to 1. Well, if you're looking at an exponential expression and you're saying, okay, well, if I take a real number, what power would I have to have in order to have it equal 1? Well, we all know the only exponent that will make any number 1 is what? 0. So that's why this is always true for logs. Also, let's look at this one. The log base b of b is equal to 1. Same reasoning, right? If we take b, right, and we say, okay, b to what power equals b, right? Well, again, just based on what we know about exponents, right, we all should know that the only exponent that will give us b back out is 1. Okay? So for any base raised to the 1 power, that will just equal the base, right? So that means that's why this is always true. Now, what about 3 and 4? Now, 3 and 4, let's look at this using the equivalence property, right? So, and let's look at 3. So 3 is kind of like very similar to 2, except they've got an x here in exponent where we could actually look at this and just say, oh, that's just got a 1 as an exponent. So let's look at this and let's use the equivalence property here. So we're going to say b raised to the x, right? B raised to the x equal to, right? So equal to the argument, b to the x. Right? Well, we get the exact same thing on both sides when we change it to an exponential expression. Now, the other thing is this, right? So what happens here? Oh, let's continue. So we get what? We get this leads to x equals x, right? So we're just using the equivalence property there, right? So anytime you take a log of the same base, so you have an exponential. So let's look at it this way too. Here's just another way to look at it. We've got this argument, right? So we've got this base here. They've got the same base, right? But this is an exponential of base b. This is the log of base b, okay? Log functions and exponential functions are inverse functions of each other, so they undo each other, right? So whatever the log is doing, or whatever the exponential is doing, the log is undoing it, and so you get the argument back out. Remember about composing functions and inverse functions, right? The definition of an inverse function is if you compose the 2 functions, you should get x out, right? So here, you're getting x out, right? Now, technically speaking, the definition, you have to choose both. But remember, exponential functions are also, think about it, they're one-to-one functions. Log functions are one-to-one functions, right? So it makes sense that they're, it follows that they're inverses of each other. And of course, it shows, okay? And again, whether you compose it this way or this way. So there, 3 and 4 is just using the fact that exponential functions and log functions of the same base are inverse functions. And so 3 and 4 is just using the definition of what an inverse is, right? And so you compose it this way, you get x out. You compose it this way, you get x out. Okay, but let's go to 4 anyway, and just show that, hey, if I, how do I want to, let me think. Let's see, how do I want to do this? I don't want to, yeah, I mean, I guess the only thing I see is the inverse, but there's another way to write this. If I do, how do I want to do this? Yeah, that's the only thing I think of. Is the inverse properties. Yeah, let's just leave it at that. Let's just leave it at that. I'm sure there's another way to show that this, but the inverse properties, the inverse functions just make more sense. But I know there's probably another way to show this using the equivalence property. It's just not coming to me right now. Log base b exponential yeah, okay, we'll just leave it at that. Now again, all you need to do is just memorize these and understand how to get them, but basically memorize them so you can apply them. And so we're going to do some examples of how to use these to solve some problems. Bye.